Earlier, we were used to designing circuits on breadboard. These circuits, after a certain level, became more complicated looking than they actually were. In addition, there was this problem of IC pins jumping out of the breadboard, which makes debugging difficult. We had a much better experience in designing circuits with ASLK kit provided by Texas Instruments. The only problem we faced was that we had to constantly refer to the pin diagram to make the connections. However, as we became more familiar with the kit, it became a lot easier. However, we also faced some other challenges.
At low frequencies, gain was very less that noise got superimposed and we were unable to make any conclusions in the reading. This is at low frequency. This is at high frequency.
Funnily, the time allotted to us worked like a logarithmic clock. When we got our problem statement, it looked like we had lots of time and too little to do. But as soon as the deadline approached, we felt a crunch of time. It was mostly because we had 5 teams and there was only one kit available, and we had to do all our experiments within the lab hours. However, we tried to overcome this problem by learning how to interface a digital oscilloscope with a computer, so that we could do the experiment in the lab hours, and we could store it in our computer, and we could take the readings later after the lab hours. Gain bandwidth product is an important factor in design. The op amps that we worked on had a maximum gain bandwidth of 500 kHz. This acted as a limitation while designing certain circuits. The op amp TL08 series manufactured by TI had a much higher gain bandwidth product, and we hope to use it in our future designs.
Time management was very important in this project. There were 5 teams selected from our college luckily, and we had only one kit. So we took turns in which team to use the kit at what time, and of course depending on our bunks and our leisure periods. But finally we managed to do the work well with good cooperation. And I learned this digital storage communication software, and this was pretty cool actually. We could actually operate a CRO from my computer using the interface mode, and we could take the different waveforms from the circuits we get, and we could actually store them in my computer and load them whenever we require. So we found it pretty useful, especially when we can't take all the readings at a time, and we took the readings during the daytime. We analyzed the data during the night time using this software by saving them in our computer. We found this particularly interesting, and this was very good.